right, welcome to another coding session. Okay, sorry if I rushed a little bit last time. I feel like maybe I did. A lot of the stuff we did last time was kind of, we'd already done it in the previous series, so it was kind of rehashing a few things, and that's why I didn't go super into detail. If you do want more detail on that stuff, you can go back and check the other series. And I have made my camera a little bit smaller in the corner here, so hopefully I don't clip off the commands so much. Let's see, this maybe my path is too long. Maybe that's the problem. But yeah, not so good for the ego, but hopefully it helps you guys a bit. Now, let's get into some code. We did enough talking last time. So I think the idea for this session is that I want to introduce variables, just the most basic of variables. So I think we're talking about something like x equals 5, and then exit with x. Something like that I feel like is the most simple thing we can do with variables. I did think a little bit about this syntax, whether like in Odin it's like this, to explicitly say that we're creating a variable. And this is just assigning a variable. And I kind of do like that explicitness. But for now, we're just going to leave it with this. So then you could also do straight afterwards x equals 4, and that would just reassign. So this is creating the variable, and this is reassigning it. I feel like it's just the most simple syntax right now. So we're going to expand our tokenizer to handle these cases. We're going to expand our grammar to handle these cases. And then I don't think we're going to make our the structure of our code more complex yet. I think we're going to leave that for the next episode. You know, once we've got all of this stuff included in the language, I feel like we've got enough complexity that it warrants giving our code a bit more structure. So we won't worry about that for now. But so that's the goal is to get the grammar and the tokenizer accepting this stuff, and then obviously generating the correct assembly to execute it. So let's start with the grammar. I feel like that's a good place to start. IDE is not happy. There we go. So I think what we want to do here is we want to say begin cases. Let's see if I can figure this out right. And then end cases. Maybe we don't put a new line. No, we do want to put a new line because it's a new thing. Okay. Looks like we probably need to put the 2 here. There we go. All right. So we have statement. That's the statement on the left here. 2. Sorry, I couldn't tell you all the syntax for all this because I don't know it. I'm just kind of like fumbling through it for now, but I'm sure over time it'll become more apparent how this all works. But yeah, so I just introduced cases, which gives us a little squiggly bracket because exit is not our only thing we can do now. We can also do an assignment. So that would be some text, which I would call identifier. Yeah, let's just do that for now. I'm probably getting this syntax a bit wrong. What I mean by that is, over here, I'm sure there's like a proper way to do it, a proper reason to have these square brackets and when to just have text without square brackets and all this sort of stuff. I don't really know. At the moment, I'm guessing that if it's in square brackets, then it represents a production, which means it represents one of these functions. You can kind of think of them as functions, but we'll get to that later. Like a program is a function that produces multiple statements, you could say, and then each statement can be one of these, can result in one of these. Yeah, so, but I don't really know. Let's see. And now, so at the moment we've got it so that you have to put an integer in both these places. But if we can only put an integer in exit, then we can't do this second line because this is not an integer. This is a variable, or I guess it's an identifier. So I'm going to add even another one down here. And I'm going to say term. I'm stealing the terminology from this guy, Pixeled. He's the guy that I got this idea of grammar from. Oh, I think I need to go like that to start a new line. Getting used to it. He called it a term. So that's also going to have cases. So if we do this, whoops. Whoa. Like that. So we can have a term which is either an identifier or it is an integer. Integer literal. We'll say that. An identifier or an integer literal. I think I'm gonna be more, I'm gonna use the full words instead of shortenings. Maybe that's a bit clearer. Shortenings instead of shorthand. Okay, so a program has multiple statements. A statement can be an identifier, like an assignment of an identifier, or it can be an exit function. And then we've got this term thing, which we're not really using yet. So what we're going to do is we're going to put that term in here. So with this grammar, it's going to allow us to do the code we did before, and you might notice that because this is a term, it should also accept an identifier. So there's an extra little thing there that maybe we'll try to handle that. Because then that becomes, no, I guess that's not really so different. Okay, yeah, probably be easier to explain as we code it. But here's our new grammar, looking very nice. Yeah, I like it a lot more than the last one. The last one was so simple. So let's go back to our tokenizer. This is the right tokenizer, isn't it? Yes, it is. This is the Bangalang tokenizer. It's my second tokenizer, I guess. I did write one for Bangalang. So we have a few more things that we can have in here now. We have this equals sign. I think that's the only extra sort of single character that we introduced. There's brackets and equals. That's kind of it. Yep. So let's just chuck that here maybe. And actually, what I would like to do at this point is I would like to make our tokens an actual struct instead of just a string. So let's go token struct, and then we can say that it has a type. We'll create an enum for that, and a value, which is the string. So if we go enum, And type, we can have like opening bracket, closing bracket, equals identifier and integer literal. Oh, integer literal. So those are all the types of tokens that we can have. And the value is like the actual string that corresponds to it. And then we're going to say, give us a array of tokens. And actually, I've just noticed here, something I kind of like to do in Odin, because you can have named, you can name the return type or name the return variable. And you could even add more. You know, I could go comma, I could return a flag to say, like, did we tokenize? Did we succeed? We'll get to that, actually. We'll probably do that at some point, but not yet. At the moment, we're just crashing, basically. So now I don't need to declare this here because we already have our tokens. So it's the return value, but also in Odin, it's a variable within the function. I think this is quite nice. So I can just use it like a variable in the function. I do need to return at the end. I can make it an empty return, which to me seems weird. This part I would like if I could just do this, but it's going to complain missing return statement. I feel like that's not necessary, but whatever. Okay, so now we want to append to the tokens a token. And we're going to go like this. And now another nice thing in Odin is that I can just go dot opening bracket. Because this is our struct literal, we're not naming the members, but because the order of the members is like this, it's type and then value, that's the order that it's taking these in, and it knows the first variable is an enum of type token type. So there's no point in me putting token type here. It's redundant. So I just go dot opening bracket. I think that's nice. Closing bracket. So there's nothing special with these ones. I can go equals. There's an equal sign. Let's just skip over this one for now, and we'll go to this is our integer literal, which I don't think we need to change. You know, that's pretty nice. But up here, this is our super specific, has to be exactly the word exit token. And we're going to change that. We're going to be more flexible. Greater than or equal to A. And in case you're wondering why this works, you know, we're saying greater than or equal to the character A, less than or equal to the character Z. It's because in ASCII, these correspond to, I mean, in the end, it's computers know numbers, right? They're just numbers. We can open this up. We can go ASCII table. Okay. I opened that page just before. All right. Hopefully this one's not so bad. So where's the actual symbol? Here we go. Printable characters. So here we go. Capital A down to capital Z corresponds to the numbers 65 down to 90. So that's what I'm actually saying. It's between, I could go 65 and 90, and that would say it's a capital letter. Same thing. But obviously, you know, it's a little more readable to actually say what characters we're talking about. Anyway, that's why that works. Actually, that should be an and. So then we'll do capitals. And another thing that I feel like should be valid is an underscore. So if we've got an underscore, that's also a valid character. And it can be the first character also of an identifier. And we're going to copy this. We're not checking the length. And then we're basically going to copy this logic, actually. Let's just copy and paste that into here. We don't have this edge case. And I'm just going to allow, like you could just have an identifier which is just an underscore. I think in some languages they have like a special meaning where it's kind of like a variable you want to ignore or something. I'm not 100% about that. It's just a feeling I get. Like I think some linters will not complain if you have something that's declared as an underscore and you don't use it, that kind of thing. So we don't need this case. It's an identifier. And we're not looking for numbers here. We're just going to look for the same set of characters. So that should loop through. And as long as it finds a letter, actually, let's put numbers as well. The first character, we'll say, or the first character cannot be a number. If the first character is a number, that's considered an integer literal. Then we're going to go into the integer literal case. Getting a bit lost here, but this one here. So it can't start with a number, but after that it could have numbers. You know, you could have like a variable which is like, I don't know, dog 1, dog 2, dog 3. You can have numbers. It's fine. So this should loop through, and as long as it finds characters that are valid, it'll build up the identifier, and then when there's no more valid ones, it'll give us the token and it'll increment our index to the correct position. That should work. So if we go, that's not going to work anymore because we've got more sophisticated tokens. But what I do want to do is just print our tokens again. Oh, Jesus. I don't know if you guys could hear that. I'm going to mute. Whew. Sorry about that. Maybe I can cut that out in post and you'll be like, what are you talking about? But it was like this loud beep. Tokens. Yeah, actually, I do have the desktop audio on a separate track, and I'm not even using it, to be honest, so maybe I'll just ignore that track altogether. But let's print out the tokens. Bang test 1. And we've got x equals 5, x at x. Well. This program is not exiting. It looks a little bit like an infinite loop. Okay. Yeah. It's because we copied and pasted. Copy pasta error. These need to be end index, because that's what's getting incremented. Otherwise, we're just looking at this index, the first index of the identifier over and over and over again and finding a valid character. There we go. Tokens. So we have an identifier of x. Let's bring up our code here. Identifier of x and equals an integer literal of 5, identifier of exit, an opening bracket, an x, and a closing bracket. Perfect. Perfect. Okay. So then we should be able to go back to main here, and instead of our sort of hacky little rushed if, we're going to go for a for, similar to our tokenizer actually, and we will move this outside of this file. soon into its own, it's going to get promoted to its own file, but not yet, not yet. So we're going to loop through the tokens. And there's two, so we're starting it here, right? We've got a whole program. So basically what we're going to loop through is statements. So let's do our switch. I am enjoying switches, so why not? In both cases, the first one, in both cases we start with an identifier, don't we? Because exit is considered an identifier now, and so is the variable if we're assigning a variable. So let's say the type, we're switching on the type, and case identifier we're going to handle, and then we have the default case, and that's all we're going to handle. Yeah, that's all we're going to handle. So here we really want to have like a failure condition, because then it's like, this is an invalid statement, man. Which is probably what no, I didn't have that down here. If you had an invalid statement before, it would just ignore it. Okay, we're getting more sophisticated. And the identifier, so in the case that we have an identifier, we're gonna do switchception on index +1. And if we find equals, we're going to do an assignment. And if we find opening bracket, we're going to do an exit. Now you might have noticed there's errors here. This is because this is kind of why I like switches in Odin. I probably mentioned it before. I keep mentioning it because I keep liking it. This is where, because we're switching over an enum, Odin expects us to handle all the cases, and it's saying like, hey, look at all these cases that you have not handled. You need to handle these. Otherwise, I'm not going to let you compile. But I can say, trust me, bro, with this partial, and that means I only intend to handle a select set of cases. I'm not going to handle the cases. Okay, so opening bracket, we already know this. We already know this one. This is where we're doing this. So, but we have some more conditions first. We have some more conditions. So we need well, we should also actually be making sure that we have another token ready, right? Yeah, this is something I think we will handle better in the future. But right now, I'm just going to put manual checks everywhere. I think in the future, we're going to have some sort of like stream where we can say, give me the next thing in the stream, and it'll give us an error if there's no more. Something so that we don't have to like continually check manually, like, hey, do we have another token, sort of thing. So I'm going to say if index equals 1 is just equals would probably be fine, but we're going to say greater than or equal to the length of tokens, which means we don't have another token. I'm going to say, did I do like a end of file? No. Invalid statement, end of file encountered, something like that. we're going to improve these later. I would really like to get line numbers and column numbers, because at the moment, if you get this error, you're going to be like, I don't know where this problem exists. So that verifies that we can do this switch. Like, this token does exist. Now, if we're going into if we have an opening bracket, we need to make sure that there's even 2 more tokens after that. So that's how we do that. Now I can say, hey, does the type equal maybe I can't do that. Oh, I can do that. Okay. Identifier and +3 is closing bracket. It would be nice if it did auto completion, if that's a valid thing. And then we're going to have an else if and this is where we're actually going to put this code, I think, because the other case is a integer literal, and that's the one we already know how to take care of. That's the one where we'd say, yep, this is our token, and we want the value of it to be moved into the register, because that's, yeah, we're just saying this is just a literal number, just put it in the exit code. This is going to be a little more complicated, and I guess actually because we've established it's an opening bracket, we know that it's an exit already. We can do something like this, and in here we can, maybe I'm going to put a comment maybe up here. Actually, we're processing an exit, so let's put the comment for exit here. So we're always going to say, we're always specifying that it's an exit syscall, and we're always executing a syscall, but it just depends what we're going to put in that register. So I think we'll leave this one for now, and after we handle the variable assignment, maybe it'll become more clear what we put in there. So let's handle the equals. This is brand new stuff here. So let's call this assign. And we need to verify that there are 2 more, no, 1 more. And then he puts a 2, because we're already verified that there's 1 more after the initial identifier, which is the equals. Now we're checking that there's 2 more, so that's the equals and the number. This is not very pretty code, but yeah, like I said, we'll fix it up later. Okay, so now some actual assembly. So first, we want to create some space on the stack. And I think to create space on the stack, we just subtract the stack pointer. Let's say NASM x86 add space to stack. Stack needs to be 16-byte line before function calls. Oh boy. Sub 16 bytes. 16 bytes. Of course, the top of the stack remains unaltered, so whatever was sitting there in memory will stay there. So I'm pretty sure we do subtract. So RSP is the 64-bit, 16 bytes, 64-bit, that's right. It's the 64-bit, isn't it? 64 divided by 8. 8 bytes. Yeah, 8 bytes. That makes sense. 64-bit. So yeah, this is a 64-bit stack pointer, and there's also ESB, which I think is a 32-bit stack pointer. So the stack pointer is pointing to the type of the stack, and it's a bit weird that we subtract it. You would think that we would add to the stack pointer and move it higher if we want to allocate more space in the stack, but it's just weird. From what I understand, the layout of the memory in the program is that, get my hands in the right place, the heap starts at the bottom and the stack starts at the top. So the heap moves up, so then you would be adding to it. You would be adding to some pointer to allocate more if you were just, linearly allocating. But from the stack point of view, you're starting it at the biggest memory address. So you actually subtract from that to allocate space into the stack. It's quite strange. So yeah, this part I'm really not sure about, but let's do it. Let's subtract from it 8 bytes, because we're gonna use 64-bit registers. We're going to say that these are 64-bit integers for now, because that's just what I've done before, so that's what I know. Okay, so we go allocate space on stack. Now what we also need to do is record where on the stack we put this variable. Because then we can refer to it later when we want to use it. We'll just do that relative to the current stack pointer. So we're going to need to keep track of our variables and our stack pointer. So just to make it extra confusing, we're going to go up with our stack pointer, because we're going to start from 0, because I find that a bit easier to reason about. And the reason it doesn't matter that we are not starting from a big number and coming down, like the stack really is because all we care about actually is the relative position. So if we put something on the stack and then we moved 20 bytes further, and that's where our stack pointer is right now, all we really care about is that the difference between these two is 20 bytes to get back to that variable. That's how we tell where the variable is on the stack. So we're just going to start from 0, and our variables will be like a map from identifier to also a pointer, right? Like a pointer into the stack. So Odin, I was looking at maps before. Here we go. This is how and we need to delete it later, so let's just do that. So we'll call that stack vars, and we'll delete stack vars later, and that's a map of, I think this is just int. It's a map of the names to the positions, so that'll do. So then whenever we allocate space on the stack, we will say, well, I guess first we need to check, is the variable already in the stack? Let's start simple and assume that it's not in the stack. So we're declaring a variable. And in that case, I think we just say stack vars. We need to verify first. Let's verify. I think actually I need to put an else here. Like these are the two valid. Sorry, I'm jumping around a bit. This is going back to this exit function call. And I'm just realizing that if neither of these two are satisfied, then we've got an invalid statement. And we're just going to say invalid statement. It's so bad. It's so bad. The error handling is so bad. But bear with me. We're going to be we're being cowboy, but eventually we'll get there. So bad though. Okay. Oh, so that's right. The reason I went down here is because we need to do something similar to this. Much simpler, but similar. We're just going to have one if statement, and we're just saying that this needs to be an identifier. Then we know what to do. Like this, right? Do we have anything after the if else in this one? Yeah, we had another print, but this is fine. So our identifier is at +2. So we take the value, that's the name of our identifier, and we say that it is equal to stack pointer. So we've matched the name to the current stack pointer. That's where we're going to put our variable. Then we sub 8, which means that maybe I'll put this after that we want to plus equal 8 to this. Our stack pointer is moving by 8. Okay. The other thing I'm a little bit unsure about is after we allocate that space, where the stack pointer is that pointing to the space that we just allocated now? Or is it pointing to after? So if we get weird answers, I've probably got that wrong and I need to adjust for it. Like it might be that I need to do this, after I increment the stack pointer, then we say that's where the variable is. That might be the case. I'm not sure. But anyway, we've allocated space for this variable, and now we need to assign the value to it, right? So we need to move to the, so because RSP is a register which holds the pointer, we need to put this in square brackets now, because that's saying what we're pointing to. It's like a dereference. It's kind of like in C++ or C, you would do this. No, you would do this to dereference, right? To get the thing that you're pointing to. It's kind of like that, but in assembly, you use square brackets around it. And then we go assign value. And we're going to do if print f line, because we need to put a variable in here, which is wait a minute. This is where it could be. Actually, there are two cases here. We actually want to deal with the identifier, the integer. I've gotten a bit confused, probably because our code is a bit confusing. But if we go back up here, see that the identifier was the first thing, then the equals, and then the integer literal. So actually, the identifier is the first token, and then this value here that we're assigning to it is this one, +2. the +2 dot value. That should go there. So we allocate space, and so because so this is where I might be getting it wrong already, because we're assuming that this sub we're kind of assuming that the sub comes after, aren't we? Maybe that's an easier way to think about it. Yeah, this is kind of the assumption we're making. Yeah, you could think of these as two separate things, right? This is probably the easiest way to look at it. So first, we're moving the value to where the stack is pointing, which is at 0 right now. And then we're saying, hey, our variable is at 0. And then we're saying, move the stack pointer forward. And move the stack pointer forward. That's like mirroring. But we might have these in the wrong order. I'm not sure. So I think that's pretty good. We are also going to need to handle the case that we're assigning from an identifier. And in that case, we will do it later. Yeah, I think we don't want to overcomplicate things right now. We can run this program without handling that case. So let's not do it right now. Okay, so we should have some assembly that that assigns our value into the stack and increments the stack pointer. So now down here, we have a better idea of what we need to do. So we still want to move something into RDI, but instead of moving just this token's value, this token value is actually the name of our variable. So we want to say stack vars there, and var pointer. I don't know if this only returns one value. It does. Var pointer. And then what we want to do is get the var offset, because we're doing it relative. So the var pointer, that's the stack pointer minus the var pointer. So that should take us back to our variable. And then, so we want to put this var offset in. And now we want to do this RSP again, like we did here. But what you can do is you can define an offset like this. You can go RSP plus, in this case, it's it's an integer. So we format an integer. So then it should be RSP plus 8, I believe. I'm really, let's see if this works. One other thing that I think we've missed out is that we need to, so for this, we've gone 4 tokens for the opening bracket case and the equals case. So if we're assigning something when we've used 3 tokens. So we add 3, and we'll just take this one off. So the incrementation is done totally in here. Otherwise, we're going to have to think about, oh, but there's the one up there, and that'll get confusing. And then, yeah, so the assignment is identifier equals, and then 5, for example. So that's 3 tokens. So that's why we're going 3, so that when we get to the top of this loop here, then we should be at the next statement. And we need to do the same thing for the opening bracket one, which will be always 4 tokens. So here we will say plus equals 4. Really curious to see what happens here. It didn't crash. That's a nice start. What does our assembly look like? So straight away, I'm a little bit unhappy with this indentation. So I haven't even read what the code looks like. I can't bring myself to look at the code because this exit and this assign, I want to be indented a little bit more. That looks better. So we assign the value 5 to the stack pointer. We're this at the top of the stack. We move the stack pointer by 8. Then we put 60 in racks to do the system call. We put the value from stack pointer plus 8 in the exit code. So that should be 8. No, that should be 5. And then we call a syscall. I think we got, wow, I think we got the right. That was the assembly that I was expecting. Whether that's the assembly that's going to work is a different question. There's a whole bunch of other stuff I was, oh my God, those beeps. There's a whole bunch of other stuff that I was doing. So hopefully I can do, there we go. There's our command, and you can see it nicely like that. Operation size not specified at number 4. Okay. So I think what it's saying is you need to say, what's the size of this thing that you're moving into the stack? You know, how many bytes are you moving to this location? And I've seen this before in our last language. And I know that for a 64-bit, where are we? Back in main, right? Yeah. I know for 64-bit, it's, I believe it goes here, Q word, which is quad word, which means 4 bytes. No, that doesn't sound right because it's 64-bit, which is 8. But I'm sure I used quad word before, so I think it's right. That's, I'm really not sure about that anymore, so let's double check that. What is Q word? Q word is a 64-bit unsigned integer or 8 bytes of data. Quad word. What's a word is 2 bytes? What is the size of Q word on a 64-bit machine? A word is 16 bits because x86 evolved out of 16-bit 8086. Oh, okay. I assumed a word was going to be 1 byte, but I guess that's not the case. All right. So keyword sounds right. If we run that, get that. Let's try our NASM command again, and it works. I'm really nervous now. LD. So we've linked. We've run the code. This is not going to work, surely. Holy shit. Wow. I still think there's a possibility that this mix-up I was talking about with stack pointers could still be there, but it's just working in this case, but with a more complex case, it'll rear its ugly head. But that's awesome. Wow. I can't believe we got one error. We got this one error because we didn't put keyword, but apart from that, it just worked. Huh, that's so cool. That's so cool. What file am I even looking for? So if I say, actually, I want an X code of 57, then I build it, NASM. I'm looking at my other screen now. You can see most of the command. LD, run it, 57. Damn. I'm really stoked with that. We're at 50 minutes now. I think we'll try, and there's a couple of cases here that we sort of ignored for now. This one here, and I'm sure there was one down. No, we did do this one. We needed to do this one. So if we can do this one up here. Oh, no. Yeah. So this is for assigning an identifier to an identifier. Let's try that. So if this is an identifier, basically, instead of saying, just put this value directly, I think this is not going to be very hard, actually. Sorry, just a second. I feel like I did some copy pasta and I thought my comments would be wrong, but they look all right. So I think we're going to steal this code here, because this is basically what we want. And actually in this case we can say if this value, if not value in stack files, I think we can just do this, yeah. Then we say, that's like undeclared identifier, right? So I'm saying that because we record our variables in the stack here, so if the identifier we're attempting to assign from does not exist yet, it's an undeclared identifier. So let's go print f line, and we can put the identifier in there. This guy is undeclared. We can test that in a minute. So then what we need to do, so we've got the var offset, and we're doing this. This is all right, except we don't want to go to RDI. Instead, we want, I think we need to have keyword again. So the difference is that we're coming from here. Okay. So we're moving a keyword to the current stack pointer from where our old variable is. That's it. That's it, I think. Holy shit. That doesn't look so complicated. So then we should be able to go like y equals x and then exit with y. This is what we just implemented. Let me get rid of this print. We don't need to be printing the tokens. We've got x equals 57, y equals x, exit bracket y bracket. Yeah, I'm pretty sure we've got the tokenizer right for this. So we don't need to be printing that out. We're just happy that we've got an exit code of 0. Okay, invalid combination of opcode and operands at NASM 7, which, just as I thought, would probably be that. So maybe keyword is not necessary here. Maybe that's where RSP comes in. I can't remember if I finished my thought earlier, but I'm a little bit confused why there would be a 64-bit stack pointer and a 32-bit stack pointer. Like, it's a pointer, right? It's just an address. Why does it need a size associated with it? I'm not sure about that. But maybe because these are both 64-bit, this keyword thing is not needed. Maybe that's what it's complaining about. I hope so, because that's an easy fix. Okay, go back to the terminal. No. Okay, let's say NASM x86 move value from one stack pos to another. You know what I just thought? Instead of figuring this out, I hope you like my laptop pictures. And instead of figuring this out, I'm just going to split it into two things. Maybe I can just say, move that into racks and then move racks into the stack pointer. Can I do that? Racks just being some register. It's just an intermediary, because maybe that works. Oh man. Ha! That's cool. That worked. That worked. Probably. Oh, what the hell? What the hell is this? Oh, it's because I'm using this printf line and putting the offset in here when I don't need to. Just say value to register. I don't know. This here feels wrong to me. I'm sure there's a better way to do it. So now let's play with if I say y equals z, that should be an undeclared identifier. Undeclared identifier z. Ooh, that's satisfying. Okay. I think this is a good time to wrap up. We're just coming up on an hour. I think we achieved quite a lot, really. We updated our grammar so that we can do assignment here. We have terms. So we implemented all of that. We generalized to a term, which could be an identifier or an integer literal, and they can be put in either of those places in the code. Yeah. And now, this is ugly and getting out of hand and is not going to be maintainable. So I think our next session, we're going to get into a bit more of a proper way to structure a compiler. We'll do some proper parsing. Yeah, I'm just trying to think if that's the right terminology. I think so. Okay. Yeah, great. Thanks for stopping by. Don't forget to put a like on the video if you're enjoying the series and you want me to continue with the project so I can gauge some interest. Yeah, ciao for now.